So, hello. What we're going to do now is we're going to apply what we learned about the different parameters of transformations to actually now graphing. Okay, so what we want to do first, always, is we always want to draw the parent function, okay? And what we mean by parent is the sine and the cosine, and for those of you in the 11th grade, also the tangent, woohoo. Okay, and make sure that you guys know these, yeah? Right, that sine always starts, doesn't really start, it's periodic, so it keeps going on, but at 0, 0. And then we can go from there, okay? So what I'm going to do is I'm going to do the transformations left to right. I always want to take care of all the stretching first because the moving left to right, up, down is easy. Okay, so what we're going to do first is we're going to vertically stretch. Remember, the amplitude is the up-down stretch. All the values. So 0 times 3 is 0, but 1 times 3 is 3, and -1 is -3, and so on. Okay, so there we go. And God knows my writing with this board is not very schön. Hopefully your graphs will be better. Okay, so I've just graphed the first one, right? So the equation of this right now would be 3 sine x because we've just applied the amplitude. Okay, so now we're going to do the next one, and this is the one that's the trickiest, okay? So remember what b is, right? B is the number of cycles in 360. So if you have a half, okay, that means you're only going to fit half a cycle in 360, right? So what this is actually doing is this is going to stretch the graph by 2, okay? So it's going to become wider. So what we're going to do is this has to do with the x values. So you're going to multiply all the x values by 2, okay? So to stretch it out. So 0, you're still at 0. The 90 stretches it, now goes to 180. The 180 now goes to 360. And look what we end up with. We end up with a stretch. Same with this, right? Oh, yes. 90 goes with minus 180, and the 180 goes to 360. And if you wanted to do 270 to 240, if you have a bigger graph, that, of course, is also okay. So there you go. So you see what happened. You now only fit half a cycle into that 360, okay? So the equation of this graph is 3 sine half x. Okay, so now is the easy bit. Once you've done all the stretching, the up, down, left, right is easy. You don't have anything in the brackets. You have no c, you have no phase shift. So there's no left, right. And then just as a d there, we're going to go 1 down, okay? And that's easy. So now just literally take all your y values and am I working with the right one? No, I'm not. Sorry, working with this one. So that's 0. That's -1. Right, so just shift it down. And there we go. So it's been shifted down, okay? Make sure that, you're neat and make sure you're using different colors. And also always, or you can use a pencil till your final one, that you're always making it very obvious which one your final one is, okay? And so your final one now is 3 sine half x. Okay, so hopefully that makes sense. I'm going to do one more now. And a reason I wanted to do this one is because it's a cosine. Okay, so remember, cosine starts at 1. Can't forget that. And the reason it starts at 1 is because you remember that it's all about the fact that it's the x, and that 0 on the unit circle, the x value is, of course, 1. Okay, so there we are. Somewhat beautiful. Okay, so again, the first thing to do is to stretch it by 3. We know how to do that. We're just multiplying all the y values. That stays. And make sure you're neat. So actually go through the 0. Oy. Shaky hand. Must practice writing on these boards. Okay, there we go. Okay, now is the tougher part, right? So this is 2. So what this means is that you have 2 cycles in 360. Okay, now what we're going to get now is we're going to get the period of our function. Remember, if you're fitting 2 cycles in 360, then the length of each period is 180 degrees instead of 360. What that means is we have to actually horizontally compress, okay, by 2, okay, because now it's going to be more squishy, okay. So again, remember, this affects the x values. So what you're doing now is you're taking all of the x values and you're now dividing them by 2, right, so that you could fit twice as much. So there we are, 270, that's about 135. My scale here is not perfect. 360, divide that by 2, and what we now have is we have 1 cycle, right? And if I wanted to do that again, I could. You can just see, oh, okay, I went 1.5, sort of, you know, I'm in the middle of the next one, and you can adjust, right? So then we're going to be here on this, and all I'm doing is I'm just drawing 1 more cycle. Okay, same thing with this, negative 90 divided by 2, and again it's moving closer to this because we are squishing it. Minus 80 is now going to minus 90, and it's pretty symmetrical. In fact, it's perfectly symmetrical, isn't it? 360, and we're going to go to 180. So you see what's happening with this B, right? You're now fitting 2 cycles into the 360. Right, so same thing with this, and 270, we're here, and then again over 1.5, sort of, just drawing 1 more cycle at exactly the same scale. Okay, and just so that this doesn't get confusing, let's just keep an eye on what we've done. So this is 3 cosine 2x, okay? All right, let's move on. Now all the hard part is done. All we have to do is we have to go, remember, inside, so this is the x, 30 to the right. And remember, when it's a negative, you always go to the right, and then we have to go 1 up. And in order for me to avoid making too many graphs, I'm going to do it in 1 step. Okay, so watch this. So I'm going to go 30 to the right and 1 up. Okay, 30 to the right, 1 up. 30 to the right, 1 up. 30 to the right, 1 up. Isn't it exciting to hear me say that over and over again? And suck. And we can do the same thing. And again, hopefully, you know, you're also trying it on your own. And if you want to, after this is done, just draw yourself a grid and see if you can recreate this. Okay, so and I'm not quite going to fit till the end, and that's fine. And just to finish off this, "30 to the right, 1 up." Almost done. And I'm always keeping those 5 points in mind. What they mean by 5 points is that always the 2, you know, it's always 1 period. So the 2 maxima and minima in between, and the central ones in between. And again, this is our final graph. Okay, so I just want to make that obvious. So again, see what happened. You probably see that it's vertically stretched, right? It's compressed, horizontally compressed, move to the right, and 1 up. Okay, very quickly, what's the maximum value here? We see that that's 4. What's the minimum value here? That's -2. What's the amplitude? Remember, that's always the absolute value of this number. If it's been rotated and it says -3, you would still put 3, okay, because the vertical reflection doesn't change. Okay, equation principal axis is always your central axis. When we graph the parent function, it's the x-axis, but since you see that you have gone 1 up, that middle axis, the equation of that is now y is equal to 1, okay? So it's basically the center line. Okay, so hopefully that helps with the transformations, and now you can go practice.